Awesome. Okay, so welcome everyone to this recording of the first, Michigan football analytics tutorial on how to use R with NFL data. So this is like, a very basic intro into how to use R and kind of load in play-by-play data, play around with it and make a basic graph. And so we'll be doing these every other Monday for like, until the end of the semester. So, I think it's like a good way to kind of like get used to working with data and just in general and like, kind of get that skill and everything. So kind of like the first thing that we have to like take care of is, just making sure we have R and RStudio downloaded. So like I'll put this link in the chat for anyone who needs it. And then like it'll also be in the YouTube description when this video goes up on YouTube in case anyone is watching on there. And then another thing is so just make sure you have R and RStudio downloaded, and then when you open it, it should look like this. So feel free to stop me at any time if it doesn't look like this for you. So the other thing is you can go to you can type in my name, Seth, GitHub, and my GitHub should pop up. And if you go to repositories and click on NFL tutorials 2022, this has all the code that we're going to go through today already pre-written, right? So this is like, in case you fall behind during the tutorial or you just need to like copy and paste something, it'll be there for you. So yeah, I'd recommend to have that open and just, just kind of there in case, you need it to happen. So we can get started, and then yeah, I'll also put this in the YouTube tutorial as well. So the first thing you want to do every time you start with like with the RStudio project is you want to click on the right hand side here. And for those of you who are opening up RStudio for the first time, it'll probably say something like untitled or something there. And then for those of us who've used RStudio before, there'll be a project name already there. So like this project, I call it NFL Tutorials 2022. So, what you want to do is you want to create a new project. And so this probably won't pop up if this is your first time, but for me, I've already created this project, and you'll want to go to new directory and then new project. And then you can make the directory name of this project, whatever, right? And so this is just a good way to stay organized and kind of keep it where when you're working on just your NFL data, you have it in one directory. And when you're working on, maybe a school project, you have it in another directory. And so it's just like it's a good way to just create, your new project. You can call it like NFL data, 2022 or something, because that's what the season is right now. And then next year you create NFL data 2023, and you can go back and forth between them. So once you do that, you want to hit create project. And so, that what that'll do is that'll create a new project for you, and it'll take like a minute to open, but that's a good way to kind of keep your data organized and everything. So I'll give you guys 30 seconds to a minute to do that. Let me know if there's any trouble opening up a new project on RStudio if anyone's not able to get it. Okay, was everyone able to get to this spot right here where they kind of have like this blank slate to work with and inside of a new directory? Or did anyone have trouble with that?
Mine looks like it has like some words on it. Like, I don't know.
What do you mean?
Wait, hold on.
I think you're looking at the console. You can go to the top right-hand corner there, and it's like a screen on top of a screen icon. And it should, like, if you click that, it should go to how Tetris looks.
Oh, okay.
You got
See
it,
that?
Ben? Okay. Cool. But yeah, it might be like fully open like this or something when you open it. So if you click, so like what we're gonna do when we work with RStudio, right, is we're gonna write code in the top left corner. We're gonna look for error statements in the bottom left corner. We're gonna have what data sets are available to us in the top right corner. And then the bottom right corner is for files, plots, packages, all that stuff, right? So, you know, you can close them, open them with these buttons and stuff, but I like to keep, like, you know, the 4 windows open for writing code and everything. So, and I think that's it's kind of like the way that I think a lot of people do it. So the first thing you do, if this is your first time, you know, ever using RStudio, or if you haven't installed these packages before, what you'll want to do is you'll come and you'll want to install each package, right? So you want to do install.packages and tidyverse. And so what this package is this is all the functions that you want to do in R that are, you know, basic data analysis functions that you need, and it's all contained in this one package here called tidyverse. And so, you know, once you type that out, there's a couple ways to, you know, run code in R. So either you can highlight the code if it's like a long chunk, you can put your cursor on the line that you want to run. And for both of those, highlighting and putting the cursor, you're going to hit Command and Enter on a Mac, or Command and Return on a Mac. And then for Windows, I believe it'd be, you know, Control and Return or Enter or something similar. So that should run this line that will install the tidyverse package for you. Or, you know, if the Command Enter, Control Enter is not something you want to do or not working for you, highlight it or just place your cursor on the line and click this run right here, right? So it says, you know, it'll run the current line or selection. And the good thing is it gives you the keyboard shortcut that you need to run the line if, you know, what I said wasn't able to work for you. So we're going to do this for a couple packages. We're going to install the tidyverse package, which is what you'll basically use every time. And again, you only have to run these one time as like a RStudio user. Once you install these packages, all you'll have to do is load them from today on out. So the tidyverse package will be run and installed, and that'll take a little while to run. We'll also want to install the NFL Fast R package, which has all of the NFL data, the team logos, the team colors, everything that we need there. And then, like I just mentioned, we want to make plots with team logos. So the GG image package is going to allow us to have the capability to do that with images. And then we'll also want to install the GT package, which is everything we need for making tables. And then we also want to install the GT extras package. So this is some cool things that we can add on top of our table, like that make it really nice looking and kind of give us some flexibility. So we'll see that come to fruition later on in the tutorial. But these are just the 5 packages we want to install today. I'm sure there'll be packages you want to install in the future. So you can kind of just follow this format, type out install.packages, put your quotes, and put the package name in between the quotes. So you can run all of these at the same time if you want by highlighting all of them and clicking Command Enter. I'm not going to run them because I've installed these packages before, but feel free to do that. And let me know if there's any trouble that you run into installing them. Cool. Okay, so now once we've installed them, we have to load them in. And so this is something that you'll do every time you run a RStudio project, right? You'll want to load in these packages. Every time you open up the RStudio session, you're going to have to load in your packages. And so the way we do that is we do library tidyverse. So see, we installed the tidyverse up here. So now we can load that in and we can kind of see what this looks like when we run it, right? So I just hit Command Enter and it'll load in this package. And you don't worry too much about these warning messages. It just shows that the version of R that I have, the package was built under a different one. But as long as we see that, it attached these packages correctly and everything, we're good there. We'll also want to, load in our NFL Fast R library. We'll also want to do our GG image library, and we'll want to do our GT table library, right? So these 4 packages are what we're going to load in. We're not going to load in GT extras right now because I'll show you something about that later on. That's kind of cool. So, just once you type out these lines, just highlight it. Or you could just individually go down each line. You could click run and just load in each package, right? So I'll just click run and go all the way down and I'll have all my packages loaded. And so that will allow us to do, different things with how we work with it. So let me know if anyone has trouble loading in their packages, if the installation didn't work or anything, and we can try to figure that out.
When I loaded the tidyverse package, it says there's conflicts for filter parentheses and lag parentheses. I have no idea what any of that means.
Yeah, so that'll be fine. That's just kind of saying that, again, like something that we're working with, it was built under a different version, but the filter and lag functions will still work fine for you.
Okay.
Yeah.
Cool.
So yeah, it's just saying that like these 2 filter and lag kind of appear in the dplyr package and the stats package, but it'll be fine because dplyr is right there for you anyways. So, okay, cool.
So when I installing the packages, it gives me error in install packages unrecognized response.
It said, what was the error statement that it gave you?
It said error in install packages unrecognized response.
Unrecognized response.
Yeah.
Oh, okay. Did you here? Maybe if I'll throw this in the chat. Try to run that line that I just sent in the chat exactly.
Yeah. I ran the first 5 lines, and it turned out that the packages are like error in installing packages, and it's unrecognized, and not, I don't know why.
Okay. So do you have the R downloaded as well as RStudio?
Yes, I have both.
Okay, let's see. Let's try to Google this and
Yeah, and I can share my screen if it's needed.
yeah, okay. Actually, yeah, let's do that so I can look at it. Let me give you screen sharing capabilities here.
Okay. So so here's my screen, and so these 5 lines, when I click run,
Click now. Click now.
okay. So yeah, I will click no for all.
Oh, okay. So the other ones are installing. It's just I think it's just GT extras that's not installing for you. So it says, do you want to install? Okay, so that's actually that's not a big deal. So just take out line 5 and And I'll talk to you after about like how you can fix that later on.
Okay.
Basically you'd want to go to his GitHub and download it differently, but you don't need that line too much. So as long as does like lines like 7 through 10 work for you?
Let me try right now.
You're gonna need quotes around those packages.
So it said there's no package called, so I believe it's still not installed.
Oh, shoot.
Yes.
Aaron library tidyverse. There's no package tidyverse. Hey, can you just try to run line 1 and not any of the other lines after that?
Say line 1.
Yeah, just line 1.
Okay, to run this line.
Yep. Mhm.
Okay. So it's the same thing. I don't know if I should restart.
Yeah, here, yeah. Why don't we try to restart it here then?
Sure.
Okay, now click no. Oh. So you just restarted it. So you can just click no this time because it's already restarted.
So do I need to type yes or no here? So I saw the last line on the console panel. Do you want to install? So I believe I need to reply right.
Yeah, type no and then click enter.
Okay. Let me see.
If you drag that bar in the middle to the right, you can like see the whole thing better.
I
Yeah.
see. So no, I will. Oops.
Oh,
Type 3. No.
okay, now try to run line 7.
Okay. So it's still not installed.
Try to put quotes around tidyverse, I think.
This.
Yeah, try to put like a quotation mark on either end.
Sure. It still didn't work.
Okay. Okay, how about once I go through all the code, I'll look at it after. I think could you just go through and like type out like the code with us and then like we'll look at it after and then we can try to like run it all.
Sure.
Okay. Sorry I wasn't able to figure that out
Um,
quickly. Okay, I'll screen share again here. Okay. So for everyone that loaded the packages, we're able to get play-by-play data. So what we're able to do is we'll want to call our data frame play-by-play, like so to short, we just call it, PBP to stand for that. And then to make a data set in R, what you're going to want to do is you're going to want to create this arrow. So it's a less than symbol and then a line that makes this arrow. And so then one of the functions that you can use, you can see that from the NFL Fast R package that we loaded in right here, we can do this load play-by-play data set where it'll load the play-by-play data from each season. So just to get like the most recent years of it, we can do 2021 through 2022. If you just wanted 2022, you could just type 2022, but if you type play-by-play arrow and then load play-by-play and run that, it will load in the play-by-play data. And then again, it gives like this warning message that you don't really need to follow. But so yeah, if we go from there, and then Oh, I forgot to mention this, but if you want to like ever create a new script for some other code, you can do it up here where you click like this plus sign and then our script. So like if we wanted to like, create play-by-play data that was like just 2019, we could type it on this script just so it doesn't, be in the same script as the 2020 code. And then like I don't need to save that. Okay, so now one of the things you'll want to do is you'll want to check how many rows are in your data set just to get like a feel about it. So we can do that with n row parentheses play-by-play. And so we can see there's 53,000 rows in it, which makes sense, right? It's every play from the 2021 NFL season. And then so far we've only done week 1 of the 2022 season. So that seems like about right for all the teams over the course of a year. Another thing you can do is you can do play-by-play and then your pipe operator. So the pipe operator is the base of everything that you're going to do when you're coding in R. So for me, I have it set as when I do Command, Shift, and M, it's like the shortcut that you get with the pipe. You also could just type in the, the symbol that goes up and down, and then the greater than symbol that there too. Some people might have downloaded R earlier. So, you might still use the parentheses greater than symbol parentheses pipe. So what we can do for that is if you click on help and you type in global options, and you click on like tools, global options, you can go down to code and you can click on use native pipe, which is the the symbol, the straight up symbol and the greater than symbol, and you can do use native pipe, and that requires if you have R 4.+1. So yeah, so just make sure to click that, click apply, and then click OK, and then you should be able to do the straight up symbol and then the greater than symbol. And so what we can do out of that is we can get our first 5 rows of the data. So we do that by doing the head function. So it'll print out play-by-play head, NFL verse play-by-play data. So we know, we're doing that right. And then we can, see right here. All right, 2021 season. So 2021, Tennessee versus Arizona. They did play week 1, in the 2021 season. And we can see kind of like what was happening in it. And like if I even drag this over here in order to like rerun that, we can see some more rows start to pop up. The really good thing about using our studio is not only, do you have to do that to look at the data, you can also click on the data frame on the right hand side and it'll open up all the columns and all the rows, right? So you don't want to do this for really big data sets that are, greater than 100,000 rows or anything. But this is just really good. You can kind of just like scroll through and, this is the exact same data that we were looking at here, right? You can see the play ID, the game ID, the old game ID, they all match up. So it's really good to have this open and you can kind of flip back and forth between your script and the data set and back. If you want to look at all the column names, again, this is better for a smaller data set. You can do names, open parenthesis, PVP, which is our play-by-play data set, and then close parentheses, and it'll print out all the columns in the data set. So did anyone have trouble running those lines that we just ran there?
How did you get the second like tab or of the PvP?
If you click on it right here, it'll open it there.
Wait, show that one. Which you clicked? Which one?
So if you click right here where it says like data.
Oh, okay, I got it. Cool.
Yeah. Cool. And then so one of the functions we can use is like the select function, right? So what you're gonna want to do is type play-by-play, do your pipe. Again, if you don't have the R version, it could be this, but either one will work for me. So I'll just use this one for now. And then we can just like select some columns, right? So let's take the possession team, the defensive team, down, yards to go, and play type. right? Let's just type this out and let's see what happens when we print it. So now this is a little less overwhelming than what we were looking at before. We can just see, all right, this, first play of the year, this was just some bad data that got in there. The second play, Tennessee was, receiving the ball from Arizona on a kickoff. So we can see kind of what happened there. And then we can see on their first down, of the first play of the season, they call it a run play. So we can start to get a better feel for, what exactly is in this data set. And so, but, we noticed that like, if we're trying to measure a team's offensive performance, we don't want to have their kickoffs in there or the play types that are NA, because that can mess with our data. So we just want to create a data set that just has runs and passes. So what we're going to do is we're going to create a new data set called play-by-play underscore RP for run pass. Do our arrow, because that's how we create a data set, and then our pipe. And you could hit enter here, or you could just keep typing. I usually like to hit enter just because it's easier for me to think about stacking operations on top of each other. So we can filter. And so what filter does is we put parameters in there and it'll filter the data set for us. So we filter and we do pass equals 1 or rush equals 1. So before I show the or, I just wanted to show that typed out. Like I just want to show if we just took passes and we ran these two lines together. So I'm going to highlight it and do command enter. We can see here that we now have 24,000 rows. So these are just the passes. But if we do pass equals 1 or rush equals 1, we can run it. We can see we have 39,000 rows. So it takes out all the special teams plays that we need. And so if you wanted to do and, you would do an ampersand instead of the vertical line. And there's 0 plays now, 0 observations, because you can't have a play that's both a run and a pass. So we'll change it back to or and we'll run it and we'll go back to our 39,000 rows. But another thing is we're going to be working with the column expected points added, or EPA, which is kind of the standard to use in football analytics. And there's some plays that don't have an EPA for various reasons, penalties, they weren't charted right, different stuff like that. So we can take this filter statement we have and we can stack another filter statement on it by doing the pipe operator. And we can do the exclamation point, which is not is.na EPA, right? So if we just see down here, if we type is.na of NA, it'll say true. If we type is.na of 3, it'll say false. So if we were to not have this exclamation point here, it would only keep the rows where EPA was actually NA, but we want to get rid of all of those because we want to work with the real numbers. Like if we type 3. So, well, we can run all of this together and, we can see that actually there weren't any rows that had NA. So we're actually fine, but it's just good practice to have that. So if we run that n row that we were running earlier, we can now see that we have 39,000 rows to work with. So this takes us down from the 54,000 that, we ran all the way back up earlier when we were looking at this data set. And so now we're down to 39,000 rows. Was everyone able to get the play-by-play run pass data set?
No.
Oh, what's up?
Actually, I got stuck at the play-by-play. I sent a screenshot in the chat. It's giving me some error message I've never seen before.
Oh, okay. Let me take a look, Colton. Failed to parse file with QS. Okay. So I think for you, I think you should restart R. So if you go to, I just go through everything with help. I'm sure. So if you type in just restart R, or I guess, yeah, if you go to session and then restart R and make sure to save the file that you're working on, If you click on that, it should reload it for you and then try to like go from there, I think. Would probably the best way to do it. If not, we can figure out something else after that gets run and everything. Does that sound good?
When
Yeah,
I
it
tried
does.
when I tried the EPA function, it says error and filter object EPA not found.
Did you put a pipe between the two filter statements?
Oh wait, Adam. Let me try that. Okay, it worked.
Okay, awesome. Cool. Anything else, guys? Okay, cool. Okay, so now we can now that we have our play-by-play run pass data set that we feel is pretty clean, we can start to make some observations off of it, right? So we can take it, but we can take our data set and we can use a pipe to have some functions in it, right? So let's say we wanted to say who was the Lions best rusher these past 2 seasons. So what we'll do is we'll do filter and we'll do post team, which we know is possession team based on what we were looking at earlier, equals, so double equal sign, and then in quotes, DET. So we're going to want to use NFL team abbreviations for this, right? So if we're doing Cowboys, we do DAL, Las Vegas, Chargers, stuff like that, right? So we'll do DET. And then we also just want to keep rushes. So we know we have a rush column based on what's popping up here. So we can do rush equals 1. And then on top of that, we need to make sure that we don't have any rushers that, again, are just labeled as NA. So we do our exclamation point to say we don't want rusher player names that don't exist. So that way we only have real rushers to work with. We do another pipe to chain this filter together. So actually we could just run this. I'll just run it to show. So now, we only have Detroit's rushes in this kind of data we're working with. So we can see 429 rows, which makes sense. And so we want to do group by now because we want to take each time that a different running back ran the ball will be charted in its individual row. So we want to take those and we want to group them all together. So we want to group by rusher player name right here. So see, we got rid of the NAs, we group by rusher player name. And then we can summarize the data set. So based on these groups right here, it'll group it all together and it'll summarize. So we'll do rushes equals N to count the amount of rushes that someone ran. And then we'll also do EPA per rush. So EPA underscore rush equals the mean EPA of the rushing, right? So we can do a couple things. We could take the sum here. We could take the median. But the mean is what we like to work with. But since we're taking the mean and the average, there could be someone that had one rush that was really long and they didn't end up rushing again that season. That throws off the average. So we want to filter again. Actually, I'll show what it looks like before, right? So we see Seymour right here had one rush that went 4.79 expected points added on that play. So now that we have this data frame of the 11 rushers, we only want to keep rushers that were consistent rushers for the Lions last year. So we put another pipe in and we do filter rushes is greater than equal to 10. 10 is just an arbitrary number. You could do 15, you could do 100, it doesn't really matter. I just want to show what it's like to filter after the data set is. And so we can run that. And now we see we have 6 rushers. But we're trying to find out who Detroit's best rusher was last year. So this, is good, but it's a lot easier if it's sorted in the way that we want it. So we do another pipe and we're just chaining all these commands together. And we do arrange EPA rush. And so that's this column right here. And when we run all of that together, we can see that it puts Jefferson as their most efficient rusher last year on 15 rushes. It puts Jamal Williams as their second most efficient rusher on 153 rushes, and then goes all the way down. So just to, summarize this. So we just got Detroit's rushes, which is, post team equals DET, just got the rush, took out NAs, and then grouped by that column where we got rushes, and we put a comma because we also wanted to summarize another thing. So, we could have also, just summarized win probability added, throughout the season. So we could have done, some WPA right there. And we can run that and we can see that, this is how much win probability each rusher added through the season. So there's a lot of things you can do in summarize, which is cool. And you can chain, multiple things of those together. So on the GitHub, I have, kind of something similar to this, where, I just did like who the best quarterback was last season. Here, so that's these lines right here. I'll skip over that because of time and kind of go into making our first graph, but feel free to do that on your own time and let me know if you have any questions there. So we're gonna jump to line 61 here, maybe it's 63, I think, because I added something earlier. Yeah, we're gonna jump to line 63 here, if you're following along on the GitHub, and make our first graph. So what we're gonna want to do with our graphs is we're gonna want to compare passing efficiency versus rushing efficiency last season, and just see who's good at passing the ball, who's good at rushing the ball, or teams good at both, and we can kind of plot that. So we want to take we want to again do the pass efficiency data set, have our arrow to make our new data set, and then play by play run pass and do our pipe. And we're going to want to filter season equals 2021 because we're looking at last season, and pass equals 1, just because we just want passes for the sake of this data set. Group by the possession team, so group by post team, and do another pipe so that you can chain it together. And then let's just summarize, and let's get two things in this, right? Here we got rushes and EPA per rush. When we're working with passes, we can do passes equals N, open parentheses, close parentheses, which does our count. And then pass EPA, let's call this column. And that'll be the average EPA of a pass for each team, each of the 32 NFL teams. So we highlight that and we run it, or you can put your cursor there, or your cursor there and run it. We can open this up, right? So the Panthers were the worst passing team last year. That makes sense. And the Chiefs were the best passing team, which also makes sense. And so, when you come over here to passing efficiency, and you open it, you can sort these columns, right? So the Seahawks only passed the ball 599 times. Chiefs passed it the most, 950 times, right? So it's cool. And then, if you click there, you can sort it alphabetically. So just remember, you can come over there to that and click on the data sets. We're going to want to do the same thing for rush efficiency. So it's going to be very similar to what we did above. We filter on 2021. Instead of pass equals 1, we do rush equals 1. We group by post team, and we'll summarize rushes equal N, and rush EPA equals mean EPA. So see, we're calling our columns different: passes versus rushes, and then pass EPA versus rush EPA. Run that, and we can see our rush efficiency data set pop up here. Anyone have any trouble with those two? Okay, awesome. So now what we can do is we can create a data set called total efficiency. And so we have our pass efficiency data set, and we're going to do what we call a left join. So what a left join does is it's going to have all these columns right here and all these rows, and it's going to match it up based on the key that you give it to match up on, right? So we can see in our pass efficiency data set, we have this post team key. And we open up our rush efficiency data set, we have the same post team key. So it'll keep this data set and it'll join from the left side and add these two columns, rushes and rush EPA, onto the right side of this data set. So we have both of them in the same data set. So we do left join parentheses rush efficiency. And so you could run it and it'll figure out what the join is for you. But that's not really recommended practice because sometimes it might mess up or you might join on multiple things. So it's better to do left join by, we want to left join rush efficiency by equals post team. We open up total efficiency just to check what it looks like. And we can now see that when we had Arizona with 741 passes and 472 rushes. In this data set, Arizona, 741 passes, 472 rushes. So the left join worked. But when we make our plot, we need something to plot the team logos with. So the NFL Fast R package gives this team colors logos data set. So whenever you want to look at a data set that's not available to you on this right-hand side, you can do view with a capital V, teams colors logos. And so that'll give it, we'll see, Arizona Cardinals, they are, in the NFC West, and they have team logo Wikipedia, team logo ESPN, and team Wordmark. So we can see that they have these logos and we want to join them to this total efficiency so that we can plot the logos from the data set. The problem is this is called post team right here, that we would join it with, the column with the team names. And this is called team abbreviation. So what we're going to have to do is we're going to want to go back into total efficiency. So we're going to do total efficiency, arrow total efficiency. And, I try not to do this too often because you don't want to overwrite data, but, we feel pretty confident about making this. We're going to want to do the left join that we just did with teams colors logos. And we're going to want to do by equals, and then this C. And so what the C does is it allows us to create something that is longer than just this by post team, because post team is in the original data set, but team abbreviation is in this data set we want to join with it. So we're going to have to do post team equals team abbreviation. And this is just a single equals, right? When we do filter, we want to do double equals because we're filtering on the data. We want it to equal exactly. This is saying that we want these to be equal. So we're doing by equals post team equals team abbreviation inside of that. And if we run that, we now open up our data set that we can make our plot with. And it has all that we need to have, right? It has the pass EPA and the rush EPA that we are going to plot on the X and Y axis. And then it also has the team logo ESPN that we are going to use. So, even if we take that logo right there, like this is the logo that we're going to plot with, right? So we can just take that straight from the data set just to check it on Google. And so now we can make our first plot. So this is going to be a lot of lines of code to make this plot. So just stick with me here. I'll run it every couple lines, but we can take a look after if it doesn't work out for anyone. So we take our total efficiency data set, we use our pipe, and then we use something called ggplot. So ggplot's what you use to make basically every single plot. It's very flexible. But to access the variables inside of total efficiency or total F data set, we're gonna have to do AES. And so you can read here, it's the aesthetic mappings that describe how variables in data set are mapped to visual properties. So that's, sounds pretty confusing, but you'll see we'll do pass EPA on the x-axis and then rush EPA on the y-axis. So if we just run that, we can see we make our basic plot here in the right-hand corner. And so this doesn't have any of the team logos or anything yet because we haven't added that. All we've done is we just say we want to have pass EPA on the x-axis and rush EPA on the y-axis. So now we can do geom image. And so this will add the images, right? So again, AES to get to access column names in the data set. And we do team logo ESPN because we were looking earlier and that was the right thing to do. And we need to set a pretty small size because we don't want it to take up, don't want the logos to overlap each other. So we're going to do 0.05 size. And then this is just kind of a trick. You want to do aspect ratio equals 16 divided by 9 to make the plot look nice. So if I run just these 3 lines, we can see we have our plot pop up here, right? So pass EPA on the x-axis, rush EPA on the y-axis, all 32 team NFL logos. If you ever want to take a closer look, you can zoom in on it and you can kind of see, all right, this makes sense. The Colts were at the top of the rush, Chiefs, Rams, Bills, Packers were at top on the right side of the pass. Then we have some bad teams over on the left side. So it's definitely looking good so far. But, this gray background that's here is kind of ugly. So there's different themes that ggplot provides you to do. Theme black and white is kind of like the go-to, but there's also theme classic, and it just goes all the way down. There's all these themes that you can use. So let's just use black and white for now. And then, it's not really good to have underscores in the plot, and there should be a title. So if we do labs equals, and we can do EPA per pass to show that it's the mean EPA, and then EPA per rush. So labs stands for labels, X equals for the x-axis, a comma, and then Y equals for the y-axis. Let's run that and see what the plot looks like. And then we can add some bells and whistles to it. So there we go. It gets rid of the gray background. It changes the labels and it's looking like a better plot. But there's still stuff to add. Like, I want to know if the Ravens were above average or below average at passing and rushing. And it's hard to tell with all these logos there. So, what we can do is we can add this, really anywhere, but before I do this, so this is this is like basically the most basic code that you need to make the plot. We can start to add stuff that makes it nice. And, the next tutorial will be about making data viz look really nice. So, if you don't want to do this, you can hold off for that and just go with this plot. But we can do extra stuff and then we'll wrap up here in 5 minutes. So geom H line will create a horizontal line. You could set it wherever we want, as long as we label where we want the y-intercept. So what we should do is we should do mean, total efficiency, and then this $sign. And so what this $sign does is it accesses any column in the data set, right? So if I take this and I'll just paste down here, you don't have to do this, I'll just show it. We can see that the mean passing EPA in the NFL last year was 0.056. So that's exactly what we want to get here. I guess this is the vertical line, or sorry, the horizontal line, we'll want the rush EPA. And then let's make it a dashed line so that it's not taking up, too much attention away from the team logos. On the other end, we'll want to do a vertical line or V line. And so we'll do pass EPA this time instead of rush EPA. So we get the mean of that line type equals dashed. And again, like you shouldn't, when you're actually going through this, like you don't have to run your plot this many times. I just want to show like what each layer we're adding kind of does. So boom, we have our average lines going both ways. I also want to see if there's a correlation between the pass efficiency and the rush efficiency that each team has. So what we can do is we can do geom smooth. So this will create a line that we'll put the line of best fit for the x-axis and the y-axis. And then we want it to be a straight line so that we can see the exact line of best fit and that it's a linear trend. So we do method equals LM for linear model. Another thing that we should have is a title for the plot. So we can come back to labs here. And you can see we're just stacking these layers on top of each other, right? With these plus signs. So we come back to labs and we do EPA per pass and EPA per rush in 2021, so that whoever's looking at this plot knows that this was last year. And then for a subtitle, we can do regular season and playoffs included. This doesn't really add much, but I just wanted to like show how to include a subtitle. And then always make sure to caption your work. So I'll save by datasets, put my Twitter if anyone wants to come and look at other graphs on my Twitter. And I'll also say, you know, what this is for. So I'll make this for M fans. Or you could put NFL Fast R here because it's NFL Fast R data. Make sure to put your own name here. And then if you want to put your Twitter, you can put your Twitter. So let's run that. So there we have our first plot. Yeah, Isa, I had to plug my Twitter here. Be sure to follow it. Ask me any questions there for the tutorial. But yeah, so this is our first plot. And we can see that there's, you know, the line of best fit between pass and rush EPA is there. We can see the average lines and we can see all the team logos. So, you know, this is pretty cool. Next week, we will go into, you know, like kind of making more of these graphs and tables and making them look really nice. Like I think, you know, this plot looks good for the most part, and you know, it'll look better when we save it. So actually I'll show that right before we end here. So if we do GG save, and we can, you know, we should be pretty descriptive with the labels. So we'll do pass rush EPA 21.png. I usually do width equals 14, height equals 10, and then DPI equals retina. I don't exactly know what DPI equals retina does, but I've seen smart people do it before, so I do it too. And we can save that plot. And so now to access the plot, what you have to do is, you know, you can type in this is why at the beginning, you know, I wanted everyone to create a directory, because you can type in NFL tutorials 2022 if you called it that, like I did, and you have your plot right here to open. You can go text this to people, share it, you know, post it on Facebook, whatever. And we can see how our team logos look, our title and subtitle, our labels, our lines that we added, everything shows up from saving the plot. So I didn't get to do everything I wanted to do. So that's, again, all on my GitHub. If you want to, you know, put the title and subtitle in the middle and make your first table and everything, we'll move that on to the next tutorial 2 weeks from now. But yeah, for everyone that came, yeah, thanks. I appreciate it. You know, always feel free to give feedback after these. And then for everyone watching on YouTube, you know, feel free to message me. And if you run into any issues, and I'd be more than happy to help. So we'll talk to you guys in 2 weeks. And then of course, for the people that are live, I'll stay after and try to help. I'll just stop the recording so that nothing is personal is being shared or anything. But yeah, thanks guys.